I want to introduce our second speaker for the night, Zeke Kossover, and he's going to actually take water apart for us. He's going to go do the opposite of what I did here. Zeke?
So the origin of my part of this presentation was I went to Walgreens and I said I'd like some hydrogen. And they said to me, we're fresh out today, but we have this lovely bottle of water you can buy. And they said, you know, some disassembly required. Thank you, I appreciate the sympathy laughs. So what's really interesting is the fact that you can take water apart at all. We live in an age where you're not surprised by this. This isn't magic or sorcery, but I'll get it started for you so you can see what's happening. This is a computer power supply that I stripped out of my boss's secretary's computer. She doesn't actually know yet. So, and we've connected it up, and I'm running electricity through water that has an electrolyte in it, just a material that makes the water conduct electricity a little better. I'm using sodium sulfate, but you can use things like Epsom salts as well. And when I'm running the electricity through the water, the electrons are driving, pulling the water molecule apart. Because what happens is that the water stays together initially. Here, let's see if we can make you see that. I don't know if we can get that on the screen. Can you? So one electrode has more bubbles coming off of it than the other. Thank you very much, Rick. One of them has more bubbles coming off of it than the other. The one with more bubbles is the hydrogen side, because water has twice as many hydrogen atoms as oxygen atoms. You all are nodding very appropriately there. I'm glad you've learned something in school. I was a high school teacher for 21 years. It makes me feel good. And so as we run the electricity through the water, it allows the hydrogens and oxygens, which were previously sharing electrons with each other, to now have enough electrons so that they don't have to share anymore. Apparently, it's scarce resources that makes things want to share, and if you give everything as much as they would like, then they separate off and are all happy by themselves. And so we get more hydrogen than we get oxygen. Now, I'm going to spend a moment showing you how to make this yourself, because it continues to be the case that they don't have it at the store. And so there are a couple of little secrets for making this work. So you too can tear apart your boss's computer to get a power supply for it. It works just fine. The electrodes need to be made out of something that is not very reactive to oxygen. So normally if you were to make the electrodes, say, out of like paper clips or something, they will very rapidly corrode from the oxygen that's coming off. You'll still be able to make all the hydrogen you want, and of course that's the good stuff. I mean, oxygen, sure, it helps you breathe, but hydrogen's the stuff that blows up. So you'll still be able to make hydrogen, but the oxygen will go into the iron of the paper clips and make it rust, which is exciting, I suppose, in its own way. But you'll need something else that will not rust in the presence of oxygen, and that's stainless steel. So that does a great job for it. And so you can just use the stainless steel wire that you can buy at the hardware store. Sometimes it's called baling wire, but you'll be able to recognize it because if you bring a magnet, it won't stick to it very well. It usually will stick a little bit, but not strongly attracted to it. You can also make one in a slightly different way using some rubber bands. So if you take a rubber band like this and wrap it around the battery a few times this way, and then wrap another rubber band around a battery, a little 9-volt battery the other way, then you can stick some stainless steel screws on top of the battery, like this, and you can kind of make them stay in place. But if you were to drop that into the electrolyte right away, that wouldn't work as well as you would expect, because electricity would be able to get in between the two poles of the battery, and it wouldn't necessarily go into the screws. But if you use some clay, and not Play-Doh, Play-Doh will not work for this. You'll see why in a second. You want to use plasticine clay, modeling clay. Then you can cover it over until you have a little device that looks like this. And then you can put it in a cup and pour some of your electrolyte on the top of it. Oh, here, let me put it up on the, here. And then you can get bubbles of hydrogen and oxygen coming out. Your very own source of hydrogen. Now, capturing the gas is a little bit more difficult. I greatly favor the methods of the old school, so you should break some thermometers, get all the mercury out of it. If you weren't here for the earlier part, no, you'll just be confused. But you can actually do a simpler thing. You can take a test tube and fill it up with the electrolyte and turn it upside down over the tops of them. And that's what I've done here. I'm capturing the gas in them by having the gas bubbles up into the test tubes. Now, once you have your hydrogen and oxygen, you're probably wondering, what should I do with it? Well, what you can do with it is a variety of exciting activities. The first of which is that you can set the hydrogen on fire, which I think is exciting. Oh, safety first. She's Ron's lighter. So we'll light a little splint. Really? We'll light the splint and put it inside of the hydrogen. So I've got some I made earlier right here. Oh, that wasn't that exciting. So when I put the hydrogen inside, when I put the splint, the hydrogen, you might have heard a little pop, maybe? Yeah, that's the hydrogen burning from it. And I don't understand the whole humanity thing, but we'll just stick with this for a moment. And now I'll do it with the other one, which is oxygen. And you can't actually burn oxygen. In general, burning is when something combines with oxygen. Oxygen doesn't really combine with itself, or at least not in public. And so, but what oxygen does is it makes other things burn better. So what I'm going to do is I'm going to light this splint on fire again, and then I'm going to blow it out, and then I'm going to put it inside the oxygen, and this splint will perhaps be still hot enough that it can reignite inside the oxygen gas. So let's give that a go. So it reignites when you put it into the gas, because the splint was still red hot, and in the presence of all that extra oxygen gas, it made it easier for it to catch back on fire. But that's not what I brought you here today to look at. See, the hydrogen didn't make a very big explosion earlier because it didn't have very much oxygen mixed with it. Remember, I said oxygen is what makes fires go, and there was only a little bit of oxygen had a chance to get into the hydrogen. what if we could mix hydrogen and oxygen together before we set it on fire? That would be dramatic. However, my building manager, when I told him that, said, no. And if you had met Chuck, you would understand that that is not, you don't argue with him. So we spent some time trying to contemplate what might be a better thing, and he said, well, perhaps smaller would be good. And so I found an activity that's a little bit smaller than that. So inside of this little tube right here is a little bit of water with a little bit of that electrolyte added to it so that it conducts electricity better. And it's got 2 pencil leads right there. Can you all see them? Plain, ordinary. Actually, each one's only half a pencil lead. Don't want to be crazy extravagant here at the Exploratorium. And what I'm going to do is I'm going to hook it up to my power supply so that it'll start making hydrogen and oxygen inside of it. So let's get that going. Well, actually, I'm going to put this is a little container to grab a little bit more water. I'm going to put that on the top. And I'm going to connect up my power supply to this now. You'll notice it's not dripping yet. But now it's starting to drip, and gas is beginning to build up in the top. And that gas there is not the hydrogen and oxygen separated this time. It's a mixture of hydrogen and oxygen together. Happy. However, it would like to be even closer together than it currently is. It would like to give off its energy in a dramatic fashion. And instead of just being a little explosion, like these little pops that we've had, with any luck, it'll be a bigger explosion. Reaction happens very quickly. So I'm waiting for it to bubble its way out. Now, once it's in there, I need a way to actually make it do the exploding, but that's okay. I brought a Tesla coil with me. And so we're ready. We're going to give this a go. So now, if you just imagine that somewhat larger, maybe when we wrap around the table again, we'll have a chance to do it with a larger balloon next time. If you were interested in how any of these things were made, the battery, this design was by a friend of mine named Eric Muller, who works here at the Teacher Institute at the Exploratorium, developed this. The design for this was developed by folks at Flynn Scientific, and I can show you how any of this works if you'd like to do it in your house or in your classroom or with your kids. Come see me after the show. Thank you very much.
Zeke Kossover. See, now that's something I wouldn't have done, is put the oxygen and the hydrogen together in one place.